Hello, boys and girls. In lesson 8.3, we will determine an appropriate sample of a population and identify misleading statistics by analyzing the given data. So let's take a look at an example. Logan wants to survey students in his school about their favorite and least favorite ice cream flavors. So let's describe a possible sample Logan can survey instead of surveying the entire school. So here, answers will vary, but the sample must be random and represent the entire population. So, for example, Logan can stand in front of his school, and as students are walking into the building, he can randomly select 100 students to ask what their favorite and least favorite ice cream flavors are. Let's take a look at an example. Suppose that researchers sampled attendees of a certain movie and found that the mean age was 17 years old. Based on this observation, which of the following would be most likely? The mean age of all the people who went to see the movie was 17 years old. That's quite possible. But let's continue looking to see if there's yet a better answer. Because again, they're asking for the most likely. B states about a fourth of the people who went to see the movie were older than 51. We have no way of knowing that, so therefore it cannot be B. The mean age of all people who went to see the movie would probably be in an interval around 17 years of age. That is between 15 and 19. This selection, C, is a better answer than A. D states the median age of those who attend the movie was 17 years old as well. We have seen from other examples that the mean and the median quite often do not match up. Therefore, C would be the correct answer. So let's try to figure out whether the following are random samples from the given population, and let's explain why or why not. If the population were all students in school, can we use a sample that includes every fifth student in the hall outside of class? This would not make a good random sample because not everyone would be in the hall. If we think of the structure of our school, math and English are usually a double period. So when the bell rings, those students would not be in the hall. Therefore, we are missing a huge group of students that could potentially be in our random sample. Sometimes graphs are presented to persuade or influence interpretation and conclusions. One way to judge the accuracy of a graph is to evaluate how the graph is drawn. So these are questions to think about. Is the information presented correctly? Does the vertical axis begin at 0 or does it use a break? Are the intervals equal or unequal? Are the bars of the lines the same width and distance apart? And finally, in two graphs comparing the same kind of data, is the scale the same or different? Let's take a look at this graph. Why is this graph misleading? Well, if we go through those questions, we will see that the vertical axis begins at 0, yet the intervals are not the same. Where the first interval from 0 to 80,000 rises by 8,000, the next interval goes up by 1,000. That is inaccurate. In addition, so the actual increase in price is £2,000 from 80,000 to 82,000. This is really only 2,000. The graph shows that the second bar being 3 times the size of the first bar, which would imply a 300% increase in price, where it was actually only 3% increase in price.